All right, awesome. Great, thanks. This is joint work with Josh Hibschman, Haoqi, Zhang, and Nell O'Rourke through Design Technology and Research at Northwestern University. And the problem that we've been focusing on is basically how do we help people who are interested in learning web development, and HTML and CSS in particular, make the step from using simple tutorials and straightforward examples into creating really rich production quality designs of the sort that we've seen in all of the preceding presentations. So modern web design it's complex and it's difficult to learn nowadays because websites are really rich graphical applications. And the nice thing about the web is that even if I'm someone who's relatively inexperienced as a developer, I'm likely to be able to come across lots of interesting examples of things I might like to create myself just in the course of my everyday browsing activities. So let's say that I've come across this Airbnb website and I'd like to make a booking form like this. So I want a form that has a bunch of different cells that sort of have a columnar format, and I'd like to have everything be in a row. So I could search for a tutorial for this, but this is actually not super straightforward because it's often difficult to articulate what it is about the design that I'd like to replicate and that I need instructions for. And moreover, once you find a tutorial, it might not even be exactly right. So here is an example of a code pen or a simple example of a form that is functionally very similar and has a lot of properties in common, but you can see right away that it doesn't quite match the aesthetics of the original. Namely, it doesn't use this sort of row with these columns, distinct columns for each field that I actually wanted to replicate. But beyond that, another reason why tutorials might not be satisfactory is that they often don't reflect up-to-date best practices in front-end implementation. So the Airbnb example that I pointed out uses the display table property, which achieves a tabular layout without using a semantically incorrect table element. Whereas the toy example that we found relies on floats and clearfix, and that used to work and was in fact a few years ago the only way to do this sort of thing, but has nowadays been superseded by modern CSS. So experts know this, which is why if you know how to use developer tools and you're familiar with HTML and CSS, you'll often use the inspect element feature that's built into all modern web browsers to look at the underlying implementation. And this will often give you information that tutorials won't always convey regarding how to implement certain interesting designs using best practices. The problem is that if you are someone who is just getting yourself weaned off of tutorials, there's a lot of information here, and it's difficult to understand what's going on, which makes this task ultimately pretty intractable to inexperienced users. And so to address this, we make 3 contributions. First is we conducted a need-finding study with novice web developers to understand what exactly is challenging about inspecting HTML and CSS on production web pages. Then I'll walk you through Ply, which is the inspection tool that we built based on our results from need finding to address these challenges. And finally, I'll demonstrate how in 2 user studies it helps novices replicate complex components more quickly, as well as learn new concepts that are sort of subtle about CSS that you might not understand when you're just starting out. So for need finding, we started by surveying 20 undergraduate computer science students, and all of these people had some amount of web development experience, but it was pretty minimal. And we were asking them about their experiences learning CSS, following tutorials, and inspecting the implementations for professional web pages they encountered. And then we followed up with 10 of these users in person in an in-lab study where we gave them a bunch of examples of complex component features on professional web pages, and we asked them to use Chrome developer tools to inspect the implementation and try to get HTML scaffolds that we provided to look like the actual target outcome. And the high-level finding here was that novices overwhelmingly rely on visual intuition, but existing tools like Chrome developer tools don't actually support reasoning visually about code very well. And this is consistent with prior work on end-user programmers that shows that people really struggle to identify lines of code that are responsible for graphical outputs of interest. So in this talk, I want to talk about 2 specific obstacles that we found from need finding in the context of web inspection. The first is something we call visually ineffective properties. So if you've used Chrome developer tools before, you know that you can click a property to toggle it on and off, and it reflects the results live on the page. So here we're on the Airbnb website. We are toggling with 100%, and you can see that it adjusts the distribution of spacing for the cells. That's all well and good, except that there are a lot of properties that Chrome Developer Tools shows as active, but you can disable them without changing the page's appearance at all. So they're functionally dead code. And this wouldn't be that bad if there were only 1 or 2 of them on a page. The problem is that there's a lot of them on a page often, and there's a lot of them that appear to be relevant in a way that we found was really misleading to users. So here on the left, the red highlights are all properties that appear visually ineffective, but they appear relevant in Chrome. And the thing that's highlighted in green are the properties that are actually responsible for the layout part of the component that we're interested in. And so what we found in need finding is when the relevant code is pushed below the fold by a bunch of properties that don't seem to do anything and that people don't really understand, it makes it really hard for novices to actually understand what they're looking for and come across the correct solution. And so ineffective properties are a lot more common than you would think on production web pages for a variety of reasons. Professional web pages often have site-wide style guides or for visual uniformity, which means that things like typography and colors are applied to all of their UI components, even if they're not necessarily relevant to what you're currently seeing. Things like making websites work at all sorts of different, all kinds of viewport sizes and different interaction states also contributes to this. But what we found on top of that is that even if you were to give people only the output that's shown in green, that's not necessarily enough to help novice CSS developers understand how the code is actually producing the outcome on the page. And the reason for that is that novices are, by definition, missing a lot of conceptual knowledge that prevents them from making sense of unfamiliar examples. So what we saw was that novices particularly struggled to understand how multiple properties work together to produce a single visual outcome. And the example I want to talk about, we call implicit dependencies. So here I have on the left some text hello, and it's been occluded by this red div. And so I'd like to bring the text to the front of the display. And so one thing you might do is you might say, okay, I know the z-index property is responsible for controlling the stacking context on the page. So I'll set that value to some large positive number and hope it works. But obviously it doesn't, because this is what we get. And the solution is to add this property position relative, because the z-index property is not actually evaluated by browsers unless position on the same element has also been set to a value like relative. So in this case, there is a dependency between the z-index property and the position property at the level of CSS. But this kind of thing is like pretty preposterous to expect a novice to already know when they just want to see how some example has been implemented. And CSS turns out to be full of these kinds of dependencies that are not super clear. And so from both of these examples, we can see that there's a gap between the intuitive and heavily visual way that novices try to reason about examples and how developer tools are currently designed. And so based on this, we developed 2 design principles for learner-friendly web inspection tools. So the first is that we should hide visually irrelevant code, which both minimizes the amount of information we're overloading people with, as well as supports people in reasoning visually about what the code they're seeing is. And the second is that, on top of that, we want to embed contextual guidance to the output to actually explain how code works together to produce some outcome once you've identified some minimal subset. And this builds on guidelines from prior guidelines by Chris Quintana's group in the learning sciences around how we can design software to facilitate sense-making in the context of scientific inquiry. And if you read our paper, we elaborate a little more on the parallels between that process and web inspection. So we developed a tool called Ply, and as you can see, it's designed very similarly to Chrome Dev Tools and Firebug and those sorts of designs, but I want to focus on 2 specific features that address the obstacles that I just outlined before. The first is pruning ineffective properties. So on the left, you see what Ply's CSS output looks like to begin with when you start inspecting the Airbnb web page. And if I click this button to prune properties, you'll see that it grays out everything that's visually ineffective. And the second is that you can compute the dependencies within a cascade of match styles for a particular element. So here, if we've pruned once and now I want to know what does display table, what things depend on display table, I can click this button here and it'll highlight in green the properties that actually have a dependency, and when you mouse over one of them, it will show a tooltip that sort of elaborates on what this dependency is. And then really briefly, we can use the same sort of tooltip and annotation style to surface other kinds of design patterns on production web pages. So I don't have a ton of time to talk about this one, but visual subtypes is a pattern that production web pages use to implement components that have similarities but some differences between them. And in the paper we discussed how we use this to teach people about cascading and overriding behavior. So how does this actually work in practice? Let me try to maximize this. Great. So here we're using Ply to inspect the component that I was showing you earlier. We can hover over it to select it, and it appears in the inspector. And just like in DevTools, we can mouse over to see the children. Clicking prune here, what this does is it iteratively goes through and tests all the properties that you can see to see whether or not disabling them causes any change on the page. And as a result, it grays out everything, which means the things that are left you can toggle on and off and immediately observe what the result is. Then, if you want to look at the dependents, you just click that button. It does the same thing, but it only recomputes things on the properties that we already know are effective. And it takes the results from that, identifies what the dependencies might be, and highlights the dependents in green. And then to reinforce the dependencies between these, if I toggle the parent property on and off, it will also toggle the dependents, which sort of shows how these properties are related. Great. So how do we implement this? We call the underlying technique we use visual relevance testing. And it's based on a software testing approach called visual regression testing, which is often used for user interface code bases. So the main idea behind visual regression testing is you can take some screenshots of an application's routes, and then when you make changes to the code base, you re-render all of those pages, take more screenshots, use some image comparison algorithm to see if those differ. And if there are differences, you flag them as potential regressions in the software engineering sense, not the statistical sense, to the developer, and they can investigate that. And so the key idea that we transfer from this to our domain is that a CSS property on the page is visually effective if and only if deleting it from the page causes a regression. So to illustrate what I mean, consider the example from before, and let's say we disable the with 100% property. And if you just compare these two images, you see that there is a difference that's highlighted in magenta. And from here we can conclude that with the 100% is actually effective. And conversely, if we add some property and disabling it didn't do anything, then obviously it's not effective and can be safely removed within the context of what we're currently looking at. And so this simple idea of visual effectiveness, we also generalize to identify dependencies. So here's the example from before where we have position relative, which means the dependency is satisfied. And you can see that when you toggle z-index on and off, as you would expect, it affects the stacking context of the element on the page. But to test the dependence of position relative, we can disable it here, as I'm going to do, and then toggling z-index on and off now has no effect. And so because this property was visually effective before, but not in the absence of this other candidate dependency, you can conclude that there's a dependency relationship between these two things. And so this seems like a simple visual comparison, but it actually helps novices understand the example by surfacing conceptual knowledge about how properties relate that they might not have known beforehand. So having gone through how this technique works, I'll share how well it actually works in practice. The first study that we conducted was based on replication speed, and we wanted to understand whether pruning ineffective properties helps developers actually replicate features more quickly. So we had 12 users. This was between subjects, and half of them were randomly assigned to use Chrome DevTools, half of them in the experimental condition used Ply. And the feature that they were tasked with replicating was basically everything you see here on the screen from the IDEO homepage. So we gave them an HTML scaffold that was just, we like copy and pasted the DOM outer HTML directly from this component, and they had to basically figure out what to put in the CSS section. And so I don't have time to go too in-depth on the setup, but we defined 3 milestones for completing this appearance that basically covered a diverse array of CSS concepts and were roughly orthogonal. And the high-level result we saw was that the learners in the Ply group were 50% faster overall. This wasn't statistically significant for the final milestones, but we think that was because of the small sample size coupled with one outlier user. What we did see was that learners were 3.5 times faster to the first milestone in the group that used Ply, and this was statistically significant, as was the second milestone. And this is a pretty interesting difference because the difference between 2.5 minutes versus nearly 9 minutes to someone who is trying to make sense of unfamiliar code can be pretty significant. And so that was definitely something that we saw reflected in users' comments after the study. The second study that we conducted was more focused on conceptual learning. So how does providing embedded guidance help novice developers learn new concepts? And so we had 5 users with very little prior experience with CSS, and we used a pre- and post-test setup, which follows standard measures of learning gain. So they performed a similar task before and after the intervention so that we could track the change in their understanding. We had 2 separate sort of modules. The first dealt with implicit dependencies. That's the one I'm going to talk over. And the second one was about visual subtypes, which I didn't have time to address, so you can read about that in the paper. And this component here, which is a sticky header that stays in place as you scroll the page, was sort of the task, the artifact that they were inspecting in the experimental condition. So this is at the top, these 2 lines are sort of the core CSS implementation for that sticky behavior. So you have a position fixed property, which pins an element in place somewhere in the viewport as you scroll. And then the z-index property defines the stacking context as we saw before. And so initially, because these were very inexperienced users, none of them were able to identify a dependency between z-index and position. And after inspecting this example with Ply, all of them were. But more interestingly, they were able to articulate why this was happening and what the properties were doing together. So one user said, something about z-index would change as a result of position not being fixed, which means that position fixed is doing something beyond pinning it in place while you scroll. And this is really interesting because it shows that people who have very little experience can separate out the discrete visual effects of individual properties with the fact that there's a side effect that affects how they work together. And that's a pretty subtle piece of CSS that often takes a lot of time for people who are new to the language to learn. So 2 high-level takeaways. First is that if we want to help people make the jump from using simple tutorial examples to producing professional quality artifacts, we should harness production web pages to support authentic learning and to make these things explorable and accessible learning materials to novices. But to do that, we need tools that are capable of revealing these semantics. And CSS is actually non-trivial to understand. So there's been a lot of focus on developing tools that help people better understand interactive behavior, and that's really important work. And on top of that, we should also build tools that use visual intuition to support people in reasoning about the often complex code that is necessary to produce static designs as well. So all of this sort of comes together under the umbrella of building learner-centered developer tools and thinking about what it would look like if we took tools and instead of just making them only accessible to experts and heavily reliant on sort of static properties and calculations about the language, thinking about using visual relevance and other more intuitive organizing criteria to define the interfaces. You can ask me questions, follow me on Twitter, accept me to your PhD programs, look at our source code, and that's all I have. Thank you.
Go ahead.
Hi, Eleanor, University of Manitoba. Thanks for the presentation. Really good job. Been working in this field for 10 years in web development, and CSS is tricky. Question is, do you have any ideas how to prevent people who are new from learning actually something that seems to be true but is false? Quick example is, if you look many examples, could seem that flex 1 actually expands the flex child to the entire width, which is actually not true.
So in the flex 1 example, what is the misconception that you're interested in?
The misconception is that flex 1, for example, if you look at examples, will expand the element to span the entire width, but it's actually not true because it just divides the remaining space in equal chunks and gives the entire chunk to the flex 1 if you limit it.
So in that particular example, I think this speaks to what I see as sort of a next step for the work, which is a lot of times in CSS there are dependencies between elements where the properties that are set on each element affect one another. So in the example of flex 1, you would want someone to understand that flex 1 only expands an element when the ratio of the other elements in that flex container do not have some kind of do not override their default ratio, right? So I think that, so definitely a first step is making it clear to people and helping people draw comparisons between properties set on each element, and then generalizing this idea of detecting dependencies to be able to work on that, work in that context.
Yeah, thanks. I just thought maybe you can also pull in some source of truth, which is actually documentation and actual specification, to like back up and like as a next step. That'd be really awesome. Actually.
Yes, getting the specification in a machine-readable format is a long-standing open problem in CSS. Yeah.
I think we have time for just one more question, but you can talk to Sarah afterwards, hopefully. Go ahead.
Hi, Dennis from Bioengineering and SIGCHI. I have a question. So, from what I got is that you try to reduce visually irrelevant code, right? Do you like cross-check with other browsers and other window sizes and different OSs? Because when I write code, I check on all these different devices, and sometimes for one browser, like 50% of the code, exaggerating, looks irrelevant. But if I run the same code on a Windows machine, it is somehow relevant.
Yes.
So did you check this?
So the context that we're looking at is, so the short answer is no. And to elaborate on that, we're interested in helping people say, okay, I'm currently looking at something that I'd like to replicate as well. What is sort of the code that will help me get exactly what I'm looking at now, right? So that means that we take advantage of the fact that things like vendor prefixes that create that compatibility across browsers but aren't relevant to what you're currently seeing, and responsive breakpoints are all not relevant to the particular task. So that's very different from the general case of saying, I want to create sort of a really robust application that works in a bunch of different contexts. This is definitely only the first step to that, but it helps you understand how to create the fundamental design building blocks for that.
If you could develop it further, it would be awesome.
Pardon?
If you could develop it further, like cross-check with different sizes, window sizes, and browsers, would be awesome.
Yeah, it would be cool to think about how something like this would integrate with Browser Stack.
Okay, thanks.
Yeah.
Okay, and before we thank Sarah and all the other speakers, just a couple quick announcements.